Hi guys, how's it going? Pretty crazy times. I expected I would see you after March break. I'm sorry that's not the case, but I hope everyone's doing well. So I don't want to waste too much of your time, so I want to jump right into the first lesson for our next unit. So our next two units are still going to look at trigonometry, and it gets a bit more complex as we go through. I've decided to split up the first lesson into a couple lessons just because this is a new format for us, obviously, and I think it'll make it a bit easier. So the first lesson is all about looking at special triangles and special angles. And sometimes in math, and there's all these various different angles, such as 30, 45, 60, 90, 0, that occur quite often in architecture and construction and things like that. And so it's nice to be able to use exact values for these angles and using the side lengths that correspond to an exact value. So if we look at the first one here, we've got this 45, 45, 90 triangle, and I'm just going to show you how it's created. So let's say we take a square with equal sides. We've got 1, 1, this would be 1, and this is 1. And so we've got all the same measurements, 90 degrees in all the corners. If we cut that thing in half, exactly, that makes this angle at the top 45, this angle on the bottom 45, and our side lengths on the left and right, or left and bottom, are still 1. So what would the hypotenuse length be in this case? So we can easily calculate that. If we do, it's our hypotenuse squared equals our two sides added together squared. So this becomes hypotenuse squared equals 2, and then we take the square root. So we're going to leave it as root 2. And so that's where the exact value part comes in. So we don't have to worry about rounding problems or a whole bunch of decimal places. So we're going to work with that triangle in a minute. But before we do that, we're going to look at the second triangle here, which is the 30, 60, 90. And so in this one, if we take an equilateral triangle, so it's got all the same angles and sides. So that makes those all 60 and all the side lengths are 2. If we cut that one in half, that makes this top part 30. This angle remains 60, and the side length here at the bottom becomes 1. And in this case, the hypotenuse is 2. So if we wanted to find the length of this side, let's just call it x. I would take the hypotenuse squared and I would subtract the other side squared. So just rearranging Pythagorean theorem. So I end up with root 3. So I have my side lengths here of 1, 2 square root 3 for that 30, 60, 90 triangle, and the other one is 1, 1 root 2. And we're going to try to remember those as we go through the unit. So what we can do is we can now take those triangles and figure out the exact values for each sine, cosine, tan of those angles. So I'm just going to redraw this here. Here's the 45, 45, 91. Hypotenuse root 2. And then I'll redraw the 30, 60, 90. So one way to help, especially with the 30, 60, 90, is that always across from the 30 is the shortest side length. So 1 is the shortest side length. The next smallest angle is 60, so across from 60 gets the next smallest side length, which is root 3, because root 3 is less than 2. And then across from 90 gets the longest side, which is 2. And then always in the 45, 45, 90, I know that these two side lengths are going to be the same. So if I wanted to find the sine of 30, we're going to throw out our calculators. And we're not going to use them. And we're going to say, okay, I'm going to look at this triangle and I say, okay, 30 here. Opposite, so sine is opposite over hypotenuse, so I get 1 over the hypotenuse, which is 2. So the exact value of sine of 30 is 1/2. I can do the same thing for cos of 30, so that's adjacent over hypotenuse. And then tan of 30 is opposite over adjacent, so that's going to be 1 over root 3. And we'll rationalize that denominator in a minute. So if you want to, you can go through and complete this table. So 45 becomes 1 over root 2. Cosine, again, adjacent, gives me the same answer, 1 over root 2. And then tan just becomes 1 over 1, or just 1. And sine of 60, opposite over hypotenuse. Cos of 60 is going to be adjacent over hypotenuse, so we get the 1/2. And then the last one, tan, is going to be root 3 over 1, or just root 3. So if we were to rationalize some of these, so wherever we have a radical in the denominator, so I could change this one. If I multiply both the top and bottom by root 3, I get root 3 over 3. So that's an equivalent expression for the tan of 30. Similarly, with sine 45, I multiply by root 2, top and bottom, so I get root 2 over 2. That's going to be the same thing for this one. I think that's it. So those green ones there are just equivalent expressions that can be used. So the idea is sometimes when you have problems where you've got these angles, you can replace the side lengths with those exact values. And this is what I mean here. So it says find the missing length, especially in your answers, as an exact value. So that tells me I need to use my special angles or my special triangles. So if we look at the first one, I've got, looking for x here, I've got this angle 60 and I've got the side length across from 90 degrees, so that's my hypotenuse. So I have the adjacent and the hypotenuse. So I'm going to use cosine in order to solve for this one. So I've got cosine of 60 equals adjacent over hypotenuse. And I can rearrange it just like normal. But this is where it differs from what we've done in the past. I'm going to replace this with an exact value. So if I do that, again, we'll just go up to the table for now, but eventually you'll know these. Cos 60 is 1/2, so that one's pretty easy. So I get times 1/2. So move this over here, so I end up with this divides with this, so I end up with 2 root 3. That's it. So that's my exact value answer. We didn't need a calculator. The next one, we're looking for two things, I guess. We're looking for the y and the x. So if we start with the y looks like in this triangle is the hypotenuse, and you can try this yourself if you want. So I'm going to use this angle 30, let's say, and I've got the opposite side, which is 5 root 2, and I'm looking for the hypotenuse. So I've got sine of 30 equals 5 root 2 over y. So if I rearrange that, I end up with this. So this is where I want to replace this guy again, the sine of 30. So I say, what is the exact value of sine of 30? And I can either go to my triangle here, or I can look at the table, which you're not always going to have. So sine of 30 is going to be 1/2. So I'm taking 5 root 2, and I'm going to rewrite it like this. I'm dividing it by 1/2. So really that's like multiplication, where I flip that second fraction, so I end up with 10 root 2. So my y is 10 root 2. So the x, if we look at that one, notice we've got the same side length here for both. So that means that this angle and this angle also have to be the same, which means it has to be 45. So if I want to solve this one, really I can use cos or sine, because I've got 45 and the adjacent side or opposite side is going to be the same, but I definitely need the hypotenuse. So why don't we just say sine 45 equals opposite, which is x, over the hypotenuse, which we just found to be y, which is 10 root 2. So I end up with 10 root 2 times sine 45. So again, I'm going to replace this guy, the sine 45. And in this case, my root 2's go away, and I end up with just 10. Okay, another one to try out. So these ones were just given an expression, and we're asked to simplify it. So this one says evaluate and simplify fully without a calculator, leave it as an exact value. So I'm just going to simply replace these things. I'm going to replace tan 30, and I'm going to replace cos 45. So I'll let you try these out. See if you can do this without my help and then check your answer afterwards. So tan 30, I'm going to use the rationalized one. I've got root 3 over 3. Same with cos 45. I'm going to use root 2 over 2. So remember, I can multiply my radicals together, so that becomes root 6. And the bottom is just 6. So pretty easy. Second one, I've got 3 things going on here. So I've got sine of 60. Opposite 60 is root 3. So I'm going to use that. Tan of 45, which is just 1 actually. And then cos of 30 is root 3 over 2. So I end up with root 3 over root 3. Anything over itself is just 1. That's it. Okay, if you want, you can pause this and try the last ones. Otherwise, I'll fill this in so you can try it, and I'll go through it. So these ones, give it a try. This one, again, I've got the same angle, so that's 45, 45. So find the missing side length so I can use either sine or cosine. If you want, you can replace right off the start. The sine 45, it's up to you. Or you can rearrange it. So little radical rules here. I can simplify those radicals. 6 divided by 2, so this just becomes 3 root 3. Next one, we're looking for 2 things. So I want to maybe first find the y. So I want this guy. So I've got sine, let's see, sine of 60 equals my opposite side y over my hypotenuse 8. And again, we can replace this. There's my y. And the x, this time I have to use, well, not necessarily, but it's easiest just to use cosine 60. So adjacent over hypotenuse, so adjacent's 4 root 3, and the hypotenuse is the thing we're looking for, which is x. Rearrange this. And rewrite it like this, so cos of 60 is 1/2. So again, you flip that and multiply, so you end up with 8 root 3. Next one, a little word problem. It says the ladder is 10 meters placed against the wall at 60 degrees to the ground. Let's do a little sketch. Assuming the ladder's straight. And the wall is straight. There we go. So we've got this 10-meter long ladder. Let's call this the height. So in this one, it's pretty easy. I've got opposite, so I need sine again. Sine of 60 equals opposite over hypotenuse. Replace sine 60. So therefore, height is 5 root 3 meters. Next one's a bit trickier. So we've got cos 30, so we'll replace all these. Sine of 90, we haven't talked about the 0 and 90 yet, but if you punch that into your calculator, you'll find that it's just the value of 1, and we'll explain why later. So for now, you can just punch it in, then tan 60 is root 3. So I end up with root 3 over 2 divided by root 3. If I flip that root 3 here, I multiply by 1 over root 3, so that these guys go away, and I'm just left with 1 over 2. That's it. All right, if you want, you can please try these in IXL. If you do not have your password, you can move on to these extra practice ones and do those instead. The answers are here. If you have any questions, please let me know. Otherwise, you can go through all of this.